For my last lab, I wanted to use computational tools to solve a pretty generic physics motion problem. The issue I was concerned with was I wanted to calculate gravitational force and be able to visualize momentum and position of a spacecraft as it traveled along Earth. I was using this equation where my net force, or rather the gravity force, on one object by another is the gravitational constant times the two masses divided by the position, multiplied that by the position vector. And I'm starting with a few initial conditions, such as these. And when I was approaching this problem, I was thinking about ways in which I could code this to represent it with a computational model. And I knew that I would have to go through these 4 steps, and I'm pretty sure I can use these steps for any sort of physics motion problem that I want to apply to any system in the future. So what I do is, first I'm going to set up initializations where I have certain libraries that I want to import. I have to initialize a scene to display, the height, width, and the background color, and anything else I want to include, which includes defining constants as well. So gravity is a constant here, the masses are constants as well. And objects and initial conditions is something that I have to create next. So in this case, I wanted to create a planet using the geometrical shape of a sphere, given its position, its radii, and a color. And then I wanted to do the spacecraft as well, because those are my 2 objects in my system. And I wanted to leave a trail behind, which is important for any motion analysis to see where the different objects have gone. And then initial conditions, I have the velocity set to a y position at 2 to the 10 to the 3rd. And the momentum is just that velocity times the mass times acceleration. Don't mind the commented out things. I was fooling around with different scaling of the arrows. And then lastly, I would need to iteratively calculate the motion of an object in the loop. So here I have my while loop, and this is for 1 year's time, the motion of what a spacecraft would look like. So as I start running this, I'm going to explain what's going on in my code, or in the while loop at least. I wanted to calculate the net force of gravity based off of the equation I showed earlier, where I calculated my position from the planet and the spacecraft, and I was able to get the force of gravity once I did that. And then what's being printed out right now is the net force. You could see that it's becoming more and more positive as the position changes. And then also we're predicting new momentum and position with this net force, where the momentum is the initial momentum plus the net force times the change in time. And then the position of the spacecraft is the initial position plus the momentum divided by the mass, or also the velocity times its change in time, and that's also what you're being shown here. So let's stop this and analyze what's happening a little bit. So, like I said, I want to model the motion of a spacecraft traveling around a planet, which requires repeated calculation of gravitational forces. An important question I wanted to ask was, how does its initial velocity affect its trajectory? You can see that it was going in this circular direction, but what was happening was it was also traveling forward. It was traveling further away from the planet. So if you also saw, the initial velocity was at 2 times 10 to the 3rd. If I had changed that to any other value, I would have gotten a much different trajectory. And the reason why that is due to the momentum principle. So the net force is also the derivative of momentum, or sorry, the derivative of position divided by change in time. So that gives us explanatory power to look at the net force originally was something like a very large negative number, but as the net force became less negative, the trajectory had changed. So it's easy to think about this on not using equations, but on an intuitive level as well, of looking at projectiles. If you're throwing a ball with a different initial velocity or different initial speed, you'll notice that its path becomes much different. So that that observation is also what's happening in the lab that I did here. And the cool thing about it is that there's a power to computational modeling. It was very easy to write a program where I went through these 4 different steps, and I wound up with being able to predict the momentum and position and calculate the net gravitational force through the power of using looping in programs. Thanks for watching.